So this printer is a work in progress still, but I'm going to do a bit of a summary of where I'm at. So starting with the electronics bay, let's start down here. So 2 power supplies. This one's for the stepper motors. It's running at about, I think, like 38 volts. And this power supply is running at about 26, I think, volts. That's powering the bed, the hot end, and the rest of the electronics. Then I've got this power supply here, which powers the Raspberry Pi. So this needs to be mounted on the front, obviously, still. So like I say, it's a work in progress. So I've got two 5160 stepper drivers. I haven't put the heat sinks on because these are rated at like 10 amps and they don't even get hot for the, I think it's like 1.8 amps that I'm using them for. They've got Octopus Pro. What are these, like TMC 2226 drivers for Z and extruder. This is the speed controller for the CPAP. So I've got a nice big CPAP there. You can see the model number, pushes out a lot of air. Then I've got a bird air pump, which cools the hot end, and then I've got a fan to cool the bird air pump, which I know is ridiculous and probably doesn't need it, but this does get a little bit warm. So that's running on 12 volts, supplied by the Octopus Pro, which I actually have put a capacitor here because before I had the capacitor, when the bird air pump came on, there would be like a voltage drop and the lights would dim because I've got lights up here as well. In there's actually 2 strips. There's a UV strip and a white strip, and I made the mistake of running a common negative and then a positive for each, but the fan outputs, which is what I'm using to switch the lights, they actually switch the negative, so I've got to redo that. So at the moment it's just UV lights. At the moment I've just got the filament spool on the top, which, yeah, I need to work something out for a better solution. It's got a light switch here to turn the whole thing on. Oh, also, actually I want to mention this is being powered by one of the heater outputs, because that way I can have it not turn on until the whole thing's fully booted up, because I'm probably not the only one who's experienced the CPAP pump go full blast until the pin, until the trigger pin can, I guess, go low or whatever it needs to do. I don't know. Also, this is a logic shifter because I only get 3.3 volts maximum from the Octopus Pro pins, and this I think works better with a 5 volt input. And something which I should do is actually run the extra ground from there, because it is actually getting the ground via a different method, so it's probably not really standard, I guess, but it does work and it hasn't blown up yet, so that's alright. So in the actual printer we've got inlet for the CPAP and then an inlet for the bird air. Probably still needs to be neatened up a little bit. If we go down to the tool head, so you can see the bird air cooling that. It's kind of a little bit silly, but I just kind of wanted to go with this idea and stuck with it. Got a BL Touch back there. This is a valvenator cooler. It works really well. It's got those 2 valves and then also the nozzles there. As far as the kinematics, so it's like Core XY. There is a couple of little design flaws, and some of them I'm going to fix, some of them I just won't. So obviously having these kind of tall towers not supported at the top, it's not the best solution, but the 5mm rods do go all to the base, and it's a fairly chunky part the way I've printed it. It's not bad. I'm happy with the print quality, so although I know it's not ideal, I'm happy with it anyway. And then also the fact, the way this connects with just a 3mm bit of aluminium really to the whole assembly here. Not ideal, because technically that's going to be a point where it can actually twist, but it's not bad. In reality, it's not as bad as I thought it might be, basically. Something I do love is the way the whole frame is enclosed, and then the way these blocks are supported really well, to be honest. I think that works really well. They're just really sturdy mounts. I know they look blocky, and a lot of people will make things look prettier, but yeah, the fact that they're blocky, I think, makes them quite sturdy. There's tensioners in here to tension the belts, and then out the back, I did actually have to come a little bit back into the electronics bay, but yeah, basically this aluminium plate and then these screws, and I just have to tighten those up or loosen them to actually move the tensioner in or out. So that's how that works. The motors are NEMA 23 0.9 degree motors, and I've actually got a 30 tooth pulley on them, which you probably can't see. But yeah, so I did that because I was hoping to gain a little bit of speed, because obviously 0.9 degree NEMA 23 is definitely a penalty for speed. And you know, the idea is a little bit more torque, and then I can get that speed back with the 30 tooth pulley. In practice, I don't know if that's what I achieved. Basically, reliably, I can get like 50k acceleration, maybe 500 millimeters per second, maybe 400 reliably. I don't know, I still need to do more testing. Like when I first set this up, I was like 100k acceleration. I was like, yeah, this is awesome, but you know, I can't really, it does skip steps at 100k. So, but 50k I have been using reliably. As far as speed, I mean, this is my limitation for print speed, and I'm currently running 200 millimeters per second for print moves, and I think for travel it might be set to like 300 at the moment. So yeah, so that's working really well for me. What else? I don't know, I've got a micro switch there for that end stop, and then an optical end stop there. The bed system. So this was something I just transferred straight from my other printer, which I ripped apart to build this. It works surprisingly well, to be honest, but again, like this thin bit of aluminium, and then, you know, like technically it can wobble a little bit like that. Surprised how little that seems to affect, but I am going to redo this. So I'm going to be swapping out these bearings, linear bearing system, for some, I think they're called HGH rails. They're the 15 millimeter ones. They've got more bearing contact than an MGN rail. I think they're called HG rails. So yeah, there's going to be one of those on each side, and that gives me an excuse to basically redesign this mount, so it won't have any play in this way. But surprisingly, this little tiny NEMA 17 seems to do the job. So there's a 16 tooth pulley there and 20 tooth pulley there, but when I change the rails, I'm actually going to go to 30 tooth pulleys there, just for the extra torque. Definitely don't need the speed. What else? I've used a sign here for that side of the panel. I am going to use another road sign for the back, because I got it from the tip shop for really cheap. It's just a cheap way of getting the steel panels. And the whole thing will be fully enclosed when I finish that. So yeah, as I say, it's still a work in progress. Something else I forgot to mention is the way I have mounted the belts here. So a lot of printers, they have the belts kind of offset, which I don't love, because it seems like when the printer is changing direction, it's going to like I guess you call it racking the MGN block. That's the impression I get out of, like, for example, like the Voron and the VZ bot probably technically have this issue if it's really a thing, if it's what I'm thinking. So that's why I wanted to go for these straight belts, all coming in at on the same plane here, and yeah, I think that works pretty well. It's not dark yet, but the green filament glows really well under that UV light. 50k acceleration.